Could time actually flow backward? Time moves forward. That feels obvious. You wake up, grow older, and memories pile up behind you. You never wake up younger. You never remember the future. But here's the strange part. If you recorded the entire universe and played it backward, most of physics would still make sense. So this raises a disturbing question. Could time actually flow backward? Imagine watching a video of a glass falling off a table. It hits the ground and shatters. Now rewind it. The pieces slide together. The cracks disappear. The glass jumps back onto the table. It looks ridiculous, unreal. But here's the problem. Nothing in the laws of physics actually forbids it. At least, not at first glance. We experience time as a one-way street, past to present, present to future. This direction feels so natural that we assume it's built into the universe. But physicists call this feeling the arrow of time. And surprisingly, the universe may not care about that arrow at all. Let's slow down. In everyday life, time seems irreversible. Ice melts, people age, smoke spreads, eggs break. But none of these processes are truly fundamental. They're just patterns we notice. To understand time, we need to look deeper, at the rules that govern reality itself. Here's where things get weird. Most fundamental equations in physics work perfectly fine if time runs backward. Newton's laws, electromagnetism, even Einstein's equations. They don't prefer past or future. Mathematically, the universe doesn't care which way time flows. Forward, backward, both are allowed. So why don't we ever see time reversing? The answer comes from a single word: entropy. Entropy is a measure of disorder. Low entropy means things are neat and organized. High entropy means things are messy and spread out. And here's the rule that shapes our lives. Entropy always increases. A broken glass has higher entropy than a whole one. Melted ice has higher entropy than a solid cube. Ash has higher entropy than wood. That's why you never see things spontaneously fix themselves. Not because physics forbids it, but because it's unimaginably unlikely. Time appears to move forward because entropy increases. This is called the thermodynamic arrow of time. In simple terms, we remember the past because it had lower entropy. We can't remember the future because it doesn't exist yet, at least in an organized form. Time feels one way because disorder keeps increasing. But now comes the real mystery. If entropy defines time's direction, what if entropy stopped increasing, or even decreased? Would time reverse? On very small scales, something strange happens. In the quantum world, the realm of particles, time becomes fuzzy. Some quantum experiments appear to behave the same whether time moves forward or backward. In a few cases, particles act as if effects happen before causes. Not in a useful science fiction way, but enough to make physicists uncomfortable. At the quantum level, time's arrow almost disappears. But before you get excited, this doesn't mean you can send messages to the past. These effects are tiny, random, and uncontrollable. Still, they suggest something important. Time's direction may not be fundamental. It might be an emergent illusion. Now, let's zoom out, way out, to the scale of the entire universe. At the beginning of the universe, the Big Bang, entropy was incredibly low. That's strange. The universe started in a highly ordered state. From that moment onward, entropy increased. Stars formed, galaxies spread. Everything slowly moved toward disorder. This may be why time started flowing forward in the first place. Some physicists have asked a bold question. What if the universe eventually stops expanding and starts contracting? In a scenario called the Big Crunch, entropy might behave differently. Some theories suggest that if the universe collapsed, the arrow of time could reverse. Effects might come before causes. People would get younger. Memories would disappear instead of forming. But there's a catch. If time reversed tomorrow, would anyone inside that universe even notice? Probably not. Their brains would run backward too. Memories would still feel normal, just reversed relative to us. From their perspective, everything would still feel perfectly forward. So maybe time doesn't really flow at all. Maybe the universe is a giant block with past, present, and future all existing at once. If that's true, then time's forward and backward are just labels our minds invent. Time doesn't flow, we do. So, could time flow backward? According to physics, yes. Nothing fundamentally forbids it. But entropy makes it so unlikely that we never see it on human scales. Time may not be one way by nature. It might just look that way because disorder keeps increasing. And that leaves us with one final question. If time can flow backward somewhere in the universe, is our forward-moving reality just one possibility among many? Thanks for watching, and remember, the universe is stranger than it looks. Don't forget to like, share, and subscribe.